Okay, so we're gonna go through the test review. I just put the answers down there too, so if you don't want to watch the video, I put the PDF of this in as well. So rewrite each polynomial in standard form, identify the degree coefficient, blah, blah, blah. Okay, so standard form. Remember, when you're putting things in standard form, you need to write them in order from the greatest to least. So we've got 4x to the fourth minus x cubed minus x squared. Degree of fourth. It's not writing. Fourth degree. We're not going to worry about the name. I'll take that out of the test. It's a fourth degree trinomial. Leading coefficient is 4 as well. This one, it has 3 terms. And then end behavior. Remember, when we're looking at the end behavior, we look at these two things. The degree and leading coefficient is positive and even. So our end behaviors are there and there. So there is number 1. Number 2, simplify the expression and put in standard form. So we're subtracting, so we've got 4 minus 2 is 2, 3b minus negative 3b is 6b. So standard form, 6b plus 2. Number 3, same thing. Now we're adding common terms. So that's 7x squared. Those are common. X cubed plus x cubed. And again, remember to put it in standard form. Don't do anything silly and not do standard form and cost yourself some silly questions. All right, next ones I'm going to try standard form here first. So we've got x squared and x squared. It's a plus between them. So we got 4x minus x, that goes away. We've got negative 10x plus negative 7x, so that's negative 17x minus 12. That one's done, already in standard form. And the last one, x squared, so we got 5x squared minus negative 14, so plus, so that's 19x squared. We've got a negative x. 13 minus 2 is 11. So there. Number 6. 6 and 7 are kind of the same. I'm going to build a box. So we've got 8x and negative 1. So 3x squared minus 3x plus 3. So that's 24x cubed, negative 3x squared, negative 24x squared. Negative 3 times negative 1 is 3x, 24x, and then negative 3. And we're going to combine like terms. So you get 24x cubed. Put those two together. Negative 27x squared. Put those two together. 27x minus 3. There's your solution. Oops, took out a little bit more than I wanted to. And hit the wrong one. Okay, so there's that one. Number 7's done the same way. I'm just going to use the distributive property on this one instead of doing the box, just to kind of show you the difference. So that's, do it in green. So that's 10n cubed plus 25n squared plus 5n. Now I'm going to put them in columns. So 7n, so that's 14n squared plus 35n plus 7. Now you can just add the columns. So 10n cubed plus 39n squared plus 40n plus 7. And there is your solution. I'm going to adjust that a little bit. Somebody just kind of came online here a little bit. I'll get back to it in a second. Okay. Next one. Number 8. Okay, so we're squaring things. So remember, when you square something, it means that you take it times itself. But we also talked about the shortcut, and I'm going to do the shortcut. So a shortcut was, so if you had a plus b squared, it was a squared plus 2ab plus b squared. So my a value is 6, so 36 plus 2 times 6 is 12, times 2 is 24k. So 24k plus b squared, 2 squared is 4, so plus 4k squared. You should probably write that in standard form, but whatever. I'm gonna leave it like that. Okay. Difference of squares, you could FOIL, or again, remember, when we said we did this, if you had a minus b times a plus b, it was a squared plus b squared, I'm sorry, minus b squared. I don't know why I put a plus in there. A squared minus b squared. So a squared, a is 8, so a squared minus 25. And you're done. All right, all right, all right. Now we're going to factor. So if I'm looking at it, it appears to be the sum of cubes. So the sum of cubes, a cubed plus b cubed, that was going to be a plus b times a squared minus ab plus b squared. So my a cubed value is 125a cubed. If I take the cubed root of both sides, the cubed root, so I'm going to take again, so I'm taking the cubed root now. So my a square root of 125 is 5, the cubed root of a cubed is a, so 5a is my solution to that. My b value, b cubed is equal to 64. Cubed root of 64 is 4, so my b value is 4. So now I can go in and finish the problem. So my a value is 5a, so it's going to be 5a plus my b value 4. 5a squared is 25a squared minus a times b, so 20a, plus b squared, 4 squared is 16. There's your solution. Number 11, difference of cubes. So difference of cubes, a cubed minus b cubed, that's equal to a minus b times a squared plus ab plus b squared. And hopefully you have those formulas sitting around you somewhere close. I just always kind of remember there's one negative in there, and if it's a minus b, if it's a minus b cubed, the minus goes with the ab, and if it's not, it goes with the other one. So I find my a value. So my a cubed is equal to 8a cubed. Take the cubed root of that. That gives me a equals, cubed root of 8 is 2. So 2a. B cubed is 27. Cubed root of 27 is 3. Now I'm good to write it out. So my a value is 2a. So 2a minus my b value 3. A squared is 4a squared plus a times b, 6a plus b squared. And there's the factored form for number 11. Number 12. We're asked to divide. So I'm going to use synthetic division. If you want to use line division, have at it. There's no issues with that. Go ahead and use long division. I'm not going to use long division. I'm going to use synthetic division. So inside, I'm going to put -5 because it's the opposite. Look at my constants. I've got a 1, a -21, a -3, and a 1. Drop the 1 down. That gives me -5. 1 plus -5 is -4. -5 times -4 is 20. -21 plus 20 is -1. -5 times -1 is 5. That leaves me with a 2. That gives me -10. And in this case, I have a -9. So I have a remainder, so that means n plus 5 isn't a factor. Now I'm going to write it out. I started with n to the 4th. So n to the 3rd minus 4n squared minus n plus 2 minus 9 over n plus 5. That's our solution. Okay. Number 13. Okay, so I'm going to put a 5 in the box this time. I start with n to the 5th is 1, n to the 4th is -5. There's no n to the 3rd, so I have to put a 0. There's no n squared, so I have to put another 0. I'm running out of room. -7 and 40. Bring down the 1. Oh, this is going to be nice. That's going to be 5. That's 0, 0, 0, 0, 0, 0. And then -7, -35. And that gives me a remainder of 5. So the first one is n to the 4th. I don't have an n to the 3rd, an n to the 2nd, or an n, so it's n to the 4th minus 7 with the remainder, and you could put a plus there, of 5 over n minus 5. And there's your solution. The next one's using the remainder theorem, find f of x given k value. All right, so this is where we have to evaluate it. We're going to evaluate it using synthetic division because that's the remainder theorem that we talked about. So remember, the remainder is going to be our solution. And in this case, our k value is what we're using. It's not a 0, so just use k. So just use the number that they give you, 2. And then we start with to the 4th, so we've got a 2. We don't have a 3rd, so we have to put a 0. -2, 2, and -5. Figure out what the remainder is here. So we got a 2, we got a 4, we've got a 4, we've got an 8, we've got 6, we've got 12, we've got 14, -28, oops, +28, sorry. +28 gives me a remainder of 23. So that's my answer. 23. Number 15. We'll put -1 in our box. To the 5th is 4. We don't have it to the 4th, so I have to put a 0. Sorry about that. A 17. to the second is negative 11. Negative 10, we don't have a constant, so we've got to put that 0 and guarantee you that's going to be on the test. Okay, guarantee there's going to be one like this on the test where you got to add that 0 in there. Okay, we talked about it, and we talked about it on the last quiz. So we pull 4 there. That gives me a negative 4. It gives me a negative 4. It gives me a big number, 4. Uh, 21. Negative 21. Something doesn't look right. I'm just checking over my work because something doesn't look right. Okay. I guess that's negative 32. It's 32. I guess that's right. 23. Nope. 22. I'm just double checking my math. Negative 22, negative 22, just got awful big, so I just questioned myself. So I just was double checking my math as I was going through there, and everything looks like it checks out. So negative 22 is the solution. And remember, if you want to double check to see your answers right, you can throw it inside of there and for your x value and see if it works. But it works. It's negative 22. Okay. Number 16, determine if it's a factor. Okay, so now we want to determine if this is a factor. Again, we're going to use synthetic division. So we're going to put the opposite. 10, 14, 11, negative 1, negative 12. And again, there's no constant there, so we've got to put that 0 in there. Jeez, I could have made them a little longer. I'll bring down the 10. Negative 10, 4, negative 4, 7, negative 7, negative 8, 8, 4, negative 4, negative 4. Double check your math. That should be negative 4, making that positive 4, but it's irrelevant. It's still no. Since there is a remainder in there, the answer is no. If there's no remainder, it's yes. If there's a remainder, it's no. Next one's done the same way. 2, opposite. So we've got a 5, a negative 2, a negative 28, 16, 24, and negative 14. 5, 10, negative 8, negative 16, negative 34. And at this point, I'm kind of looking at the rest going, yeah, there's no way. I mean, there's no way this is going to be a factor of this. I mean, you can continue to work it out. I mean, negative 68, and you've got some huge number that you're going to multiply by 2. So at this point, I would stop. It's not going to work. So no. Weird that I made both of them no, but might have none test. Might make both of them yes. All right, number 18, and these are kind of the last things that we talked about. So find the zeros, real and complex, and then graph. So the first one's already factored for us, so that's good. So our zeros are 0, 1, and negative 4. But the key to this one, remember we talked about when we graph it, especially, I'm not asking for the multiplicity in the test, but remember that multiplicity has an effect on what happens to it. 0 has a multiplicity of 1, 1 has a multiplicity of 2, and negative 4 has a multiplicity of 1. So not only does that tell you the terms, but it also tells you the degree. Remember, you add up the multiplicities and you have the degree. So now we know that this is a 4th degree polynomial with a leading coefficient that's positive. So if it's a fourth degree or an even degree in positive, we know it has to go like this and like this as far as its end behaviors go. So my zeros are at 0, 1, and -4. So it's going to come down. It's going to go through -4 since it has a multiplicity of 1. It's going to start curling back up. 0 has a multiplicity of 1. So it's going to go through it. It's going to curl down. But 1 has a multiplicity of 2, so it bounces off it. And it goes up. Or something like that. Again, these are just sketches. So it's kind of what it'll look like. And the last one. So in this case, I give you one of the zeros is 2. You have to find the other ones and you have to sketch it. Well, we know one of the zeros is 2. So let's go inside of our box. We're going to use synthetic division then to actually see if it's a factor and see if we can factor the other part of it. So we've got -2 because it's a 0, remember. So we know it's a 0, so we know it has to go through that point right there. We also know it's cubic and it's positive. So, I mean, we can figure out end behaviors right now too. I mean, it's got to go like this and like this. But we have to find the other zeros. So we got a 1. Oops, lost my pen. We got a 1, a 1, a -3, and a -6. Now again, if this is truly a factor, we should get a remainder of 0 over here. So we've got 1, -2, -1, two, that doesn't work. Just looking at it, it doesn't look like it works. That's not what I wanted to happen. -2, -1, 2, -1. Doesn't work. That's not what I wanted to happen. All right. Well, let's erase that. And let's see if -2 is a 0. Okay, so I'll change that one on the assignment. I'm not going to redo my whole thing here. I'll change what the question says and edit it here a little bit. So one of my zeros here is not, and your assignment will say this. That should be a -2 is one of your zeros. So then we put a 2 there, a 1, a 1, a -3, a -6. So we've got 1, 2, 3, 6, 3, 6, 0. Okay, so that's one of my zeros. So -2 is one of my zeros. Now I'm left with x squared plus 3x plus 3. Now I have to find the rest of the zeros for that, and I'll make sure it works. Okay, so we gotta use a quadratic formula to do that, and I'm gonna go down here. So I've got room, so I've got x cubed plus 3x plus 3. We have to find the zeros by using the quadratic formula. So it's b, negative b. So -3 plus or minus the square root of b squared 9 minus 4 times a times c, so minus 12 over 2a, so over 2. So that's negative 3 plus or minus the square root of negative 3 over 2, which is equal to negative 3 plus or minus I radical 3 over 2. So they've got complex zeros, which is fine. So my other set of zeros would be negative 3 plus or minus I radical 3 over 2. So those are my zeros. Well, how do we go about graphing this? Well, we're going to put it here. At this point, we know that that negative 2 has a multiplicity of 1. It's cubed, so it's going to, so it's going to go through this, and it very well may go something like this and then up and through. Or it may go kind of through that and then curl after it. But we do know what the end behavior looks like. And you'll get one like that, and that complex zeros, and you can just give me the end behaviors and kind of, well, maybe what it looked like. Look on Desmos too, so because you'll have that at your power too. So obviously that last one's a little bit messed up. So I will fix that on yours so that yours says it has a 0 of negative 2 instead of 2. There are the answers. There you go.